Magnetism and electricity. All right, let's go. Questions. So we got 5 here, and these questions will show up again at the end of the video. Okay, so we want to know a simple circuit. What 3 items make up a simple circuit? The equation for Ohm's law. Also, the how you calculate power rating. Some examples of good conductors, and then a little bit about electromagnets and the magnetic field and how it's produced. Okay, so if you know that stuff, you'll be in good shape. So we have some concepts to go over, as well as a couple of problems with equations that we'll do towards the end. Okay, so we start just with current. Okay, so an electric current is a flow of electric charge. In electric circuits, this charge is often carried by moving electrons in a wire. Conductors allow electrons to move freely. Most metals, like iron and gold, are good conductors. Current can be direct, which is usually just known as DC, right, for direct current, where it moves only in one direction. It can also be alternating, which is usually referred to as AC, right? Alternating current, in which it reverses direction at a certain frequency. So you definitely want to be, you don't need to know really a lot more than that, but we want to be familiar with direct and alternating current and be able to say what it is in one sentence. Direct current typically is used only for battery operated devices, which would be like a smoke alarm or a remote control for your TV. However, most household appliances use alternating current. So those examples could be useful on your exam. Particles with different electric charges attract one another, while particles with the same electric charge repel one another. Okay. And circuits, transistors, and transformers. Again, you don't need to know a lot of detail, but we need to know some basics. A simple circuit is composed of a battery, a device such as a light bulb, and conducting wires, as well as an on-off switch, right? And so I think we had a question, didn't we, about simple circuit? Yeah, first one right there. Simple circuit is composed of what 3 items? So if they ask for 3, then we would say battery, device such as a light bulb, and conducting wires. But really, there is also a 4th one, which is an on-off switch. A transistor is not part of a simple circuit. A transistor is a semiconductor device used to amplify or switch electronic signals and electrical power. And then we also have transformers. So a transformer is an electrical device that transfers electrical energy between 2 or more circuits through electromagnetic induction. A varying current is one coil of the transformer produces a varying magnetic field, which in turn induces a voltage in a second coil. Let me say that one more time because that did relate to one of our questions. So a varying current in one coil of the transformer produces a varying magnetic field, and that magnetic field in turn induces a voltage in a second coil. Power can be transferred between the 2 coils through the magnetic field. Transformers are essential for the transmission, distribution, and utilization of alternating current. Okay. And then we move on to volt, watt, and ohm. We want to know the difference between these things. So the volt, which is just symbol V, is the derived unit for electrical or electric potential. 1 volt is defined as the difference in electric potential between 2 points of a conducting wire, while the watt is a unit of electrical power. The ohm is a unit of electrical resistance. So just understanding that, like those basic definitions, ohm is a unit of electrical resistance, watt is a unit of electrical power, volt is a unit for electric potential. That could easily be a question that you could see on this test. Okay, and then we jump into electromagnets and magnetic fields, which we did discuss a little bit there when we were talking about transformers. So an electromagnet is a type of magnet in which the magnetic field is produced by an electric current. The magnetic field disappears when the current is turned off. Electromagnets usually consist of insulated wire wound into a coil. In a permanent magnet, the spinning of electrons creates a magnetic field. Magnetic fields are widely used throughout modern technology, particularly in electrical engineering and electromechanics. Rotating magnetic fields are used in both electric motors and generators. A varying current in one coil of the transformer produces a varying magnetic field, which in turn induces a voltage in a second coil. So I know I've said that probably like 3 times now, right? But just to really try to drive home the point of that as a concept that you want to know, it's likely to show up. Okay, and then we have Ohm and Colomb. Okay, so Ohm's law states that, whoops, let me move to the next page. There we are, Ohm and Colomb. Ohm's law states that I equals V divided by R, which means that current equals voltage times resistance. That's what that means. Again, current equals voltage times resistance. That is something that you need to memorize. And then for Coulomb's law, it says, right, we have this more complicated equation, which says F equals K times Q1 times Q2 divided by D squared. So what is all that? So the charges, which are Q1 and Q2, are directly proportional to the force, right? And F is force, right? Where we have F equals and then all that stuff. If we increase one, we will increase the force by the same proportion. Okay. Now we go into a couple of equations. Okay, again, we have power P equals VI, right? And so that means that power equals voltage times current. We'll go back to our questions. Wasn't that there somewhere? Power rating, right? That third one there. How do you calculate power rating? Right? P equals VI. Power equals voltage times current. We need to know that one. Okay, here's another one. Another concept that's important to know. Force is inversely proportional to the square of the distance between two charges. Okay, so let me say that again, right, because it's worded a little weird. Force, right, so if we're given like a distance increases by a certain amount, like 2 times or 3 times more, and then we're asked what is the force? The force is inversely proportional to the square. Okay, so for example, if we saw a problem and they told us the distance is tripled, we know that inverse, so that's just 3, right? The inverse of 3 is 1/3. But remember that the answer will be the inverse proportion to the square, right? So that means the inverse is 1/3, and then we have to square 1/3. And 1/3 squared, 1/3 times 1/3 is 1/9. And so that would be the force, is 1/9. Okay, got 2 more here. So here we say we know that the current is 5 amperes and the resistance is 2 ohms. What is the voltage? Okay. So especially when we see 2 ohms right there, we're probably talking about Ohm's law, right? And remembering that Ohm's law says that current equals voltage times resistance, right? So then, right, they told us the current was 5 amperes, so we start off with 5. You can see that typed in here, equals V, we were not told, and the resistance we were told was 2 ohms. So 5 equals V divided by 2, right? And then we just want to get rid of that 2, so we multiply both sides by 2, and V is now by itself and equals 5 times 2, or 10. Okay. The app is a great place to practice this stuff. Lots of practice problems to help you get used to these types of questions if what I just did seemed confusing. And even if it seemed easy, you want to make sure you can do it yourself. Okay, and then power rating. Okay, what is the power rating given 2 amperes of current in an 80 volt circuit? Okay, and so again we go back to P equals VI. Power equals voltage times current, right? So that's, whenever we see ask questions about power or power rating, we know power equals voltage times current. Okay, so we were told voltage was 80 and current was 2 amperes, right? 80 times 2 is 160, and that's all we have to do. Okay, and that gets us back to our original questions, right? And so being able to solve those problems is very, very important. Like that, they're likely at least one of those is going to show up, and being familiar with these concepts as well, very important. So if you can do all that, you should be in perfect shape for this part of the exam.